Division Basics. This video is meant to give you the basic understanding of what division is before we ever start to divide bigger numbers. So division is an operation of making equal groups or equal shares. We are always dividing some amount of something into equal groups when we divide. We need to know the parts of a division problem. The amount that we start with, that's under the house, we can call it, is called the dividend. The amount that you are dividing by, which is going to end up being the number or the size of your groups, we'll talk more about that in a minute, is the divisor. So the amount you're dividing by is the divisor. And the answer up top is the quotient. And of course, I have a song to help you remember these parts because they're pretty hard to remember which is which. So it goes like this. Inside dividend, outside divisor, up top quotient, dividing all the time. Let's do it one more time. We're inside dividend, outside divisor, up top quotient, dividing all the time. And when you write a problem horizontally, the dividend, we would read it, the dividend divided by the divisor equals the quotient. Here's an example. 14 divided by 2 equals 7. And one tricky thing is to take this, be able to take this and put it into this format that we use for long division. Remember that this is the amount that is being divided, so it has to go under the division sign. The amount that we are dividing by goes outside, and the answer will go on the top. There are two main ways to think about division. We're going to use this bowl of M&Ms and pretending that it has 120 M&Ms to think about both ways that we can think about division. So when you are dividing, you usually know an original amount, the amount that you're starting with. So we're starting with 120 M&Ms. And you could know the number of groups that you need to make. So for example, if you had 12 kids in the class and you wanted to divide these M&Ms evenly among them, you would know you would need 12 groups of M&Ms. We're not talking about 12 groups of kids, we're talking about 12 piles of M&Ms so that each one of those kids can have a pile of M&Ms. So if you know that there are 12 kids in the class, you're trying to find out the size of each group. In other words, how many M&Ms each kid will get. And the answer will be 10. 120 M&Ms divided by 12 kids would give each kid 10 M&Ms. Well, there's another way to think about division. Let's say that you still know the original amount. The bowl still has 120 M&Ms. But now you know the size of each group, the amount that each kid needs to get. If for some reason you're doing a project and every kid needed 12 M&Ms, then your division problem could be to help you find out the number of groups or the number of piles of M&Ms that you could make. And if you had 120 M&Ms and each kid needed 12 M&Ms, then you could make 10 piles or 10 kids could get M&Ms. We can model division both of those ways with a picture. Let's say that you have a pile of donuts, 12 donuts, and you have 4 friends. And your division problem could be, in order to figure out how many can each person have, each friend have. So if you have 4 friends, you could divide these 12 donuts evenly among them. And you can see that you can make 4 groups easily, like this. So here's 1 group, 2 groups, 3 groups, 4 groups, and each friend could have 3 donuts. So here's one amount. So we had 12 donuts, we divided them among 4 friends, and each friend got 3 donuts. This is the type of problem where the answer is answering the question, how many are in a group? There are 3 donuts in each group. On the other hand, we could use the same problem and show the opposite opposite way of thinking about division. So let's say that these were tires, and little tiny tires, and we were going to make a car for a craft. And everybody needed 4 to put on their car. Maybe we're making a Lego craft. So the question could be, how many people can get them? How many cars could be made out of this? So here's a group of 4 wheels that could go on one car. Here's a group of 4 wheels that could go on another car. And here's a group of 4 wheels that could go on this car. So we had 12 wheels. We divided them into groups of 4. Remember here we divided the 12 into 4 groups. This is groups of 4, and we got that 3 people could participate. So in this way, the division problem was answering how many groups are there. There are 3 groups of 4. We can also think about division as repeated subtraction. If we have 24 items here, we can show repeated subtraction by taking away equal groups repeatedly, and the groups will be the size of your divisor. So I am taking this 24 and dividing it by 4. So I can repeatedly take out groups of 4 and see how many groups of 4 I had. So here would be 1, 2, 3, 4, that's one group. 1, 2, 3, 4, that's another group. 1, 2, 3, 4, there's 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 another group. So because I had 6 groups of 4, I know that my inside dividend, outside divisor, up top quotient would be 6. You can see also here 1, 2, 3, 4, 5, 6. We can see 6 groups of 4 that we repeatedly pulled out. It's helpful to remember that division and multiplication are inverse operations. We know that's true about addition and subtraction. They are opposites and they sort of cancel each other out. So if we add something, the way to cancel that is to subtract something. In the same way, multiplication and divisions are opposites or inverse operations. So why in the world is this helpful when we do division? Well, there's at least two reasons. One is that you can use this idea of inverse operations to help you solve division facts. If you get this division fact, 42 divided by 7, it's easy to think what number times 7 equals 42, because we know that the inside dividend, outside divisor, up top quotient. See, that song is so helpful. The quotient times the divisor should give us the dividend. So I'm going to think, what number times 7 would give me 42? Well, the answer is 6. So whenever you get a fact, you can always try to think backwards, because we know that multiplication and division are opposites or inverse operations. Also, it's helpful to check your work. If you did this log division problem and you got 63 as your answer, because we know that we can work backwards using multiplication, I could do 63 times 3, and if I got 189, that's the dividend that I started with, I know that I got this right. My answer was correct. And finally, don't forget the divisibility rules that we learned at the very beginning of the year. We learned divisibility rules for all of these different numbers. And I want you to think about that, because we should know that if the dividend, the number on the inside, is divisible by the divisor, then you won't have a remainder. So, for example, before I even ever got an answer up here, I should think 189. I wonder if that's divisible by 3. Well, I know a divisibility rule for 3. That says to add up all the digits and get the sum, which was 18, and then see if the sum of the digits is divisible by 3. Well, 18 divided by 3 is 6, so 3 is a factor of this number, which means that I should have no remainder. So if I got 63 remainder 1, we know that there's a mistake, and I would want to go back and solve this problem again, because I should not have a remainder. So anytime your divisor is one of these numbers, think ahead of time to yourself, am I going to have a remainder or not, and use that to check the reasonableness of your answer.